Hello and welcome to Dakota Test Prep question walkthrough. In this video, we're going to be tackling a motor overcurrent question. Very exciting stuff. Let's just get into it. Read the question here. What is the size of a time delay fuse for the branch circuit supply conductor of a synchronous motor for a rooftop cooling unit that is 240 volts, three-phase with a flaw of 45 amperes? All right, and again, as with all things C of Q, we ask ourselves three questions. What is the question asking for? What do we have? What do we need? So what is this question asking for? This question is very specifically asking for overcurrent time delay fuse. What do we have? Well, we have our motor info, but as hopefully you guys remember, even though we have the information that could possibly get us our FLA, we were actually given our FLA. So we always use what's given to us. And our FLA in this case is 45 amps. The other thing that we're given, and this is the most important thing of all, is the fact that it's a rooftop cooling unit. Cooling unit means that this isn't a regular hot motor. No, friends. No. Cooling unit means very specifically this is a refrigerant motor compressor or a cold motor. Cold motor. Cold motors have entirely different rules than hot motors. You cannot use the regular motor rules on a cold motor. Just in case you don't believe me, that's fine. You would go to code 28700. And that walks you through how to do things cold motor. So the question's never going to say anything like cold motor. It's going to say refrigerant motor compressor. It's going to perhaps use the word hermetic. But more often, it's going to say something like AC, rooftop cooling unit, freezer. So as soon as the question mentions anything that would power something cold, you need to use code 28700. Because again, hot motor rules, not the same thing whatsoever. You have to use specific cold motor rules. So the third thing we have here is, what do we need? Well, in this case, we need our cold motor rules, which again, I said were found at 28700. So I obviously know the rules because otherwise, why would I be doing this video? We are going to take our flaw, 45 amps. In order to do overcurrent, we have to turn our flaw, our FLA, into something called the LRC, locked rotor current. And in order to do that, we multiply our flaw by 6. So that gives us 270 amps. So 270 amps is now our LRC, locked rotor current. According to cold motor code, once you have your LRC, we then take a 50% of this, 50% of 270. So you can either, use the 50% or you can just divide by 2. I prefer to divide by 2 because it seems simpler to me. By 2. So that gives me 135 amperes. Now, we still go to table 13. And as with all things motor overcurrent, we always go down. There are no exceptions. Motor overcurrent, you always go down. So we go to table 13, we go down, and it tells us we would need a 125 amp. Now, the other fun thing about cold motors, is it fun? No, probably not, but I find fun in the oddest of places. The other fun thing about cold motors is it doesn't matter what type of overcurrent device you have. You just have to find your LRC and 50% of that. That's it. So it doesn't matter if you have a circuit breaker, a time delay fuse, or a non-time delay fuse. All overcurrent is treated exactly the same. If it was hot motors, regular motors, then yeah, your time delay fuse, non-time delay fuse, circuit breaker, they have different multipliers. But with cold motors, it doesn't matter. You only need to do your LRC and then 50% of that. Now, other fun thing is if for whatever reason, 50% of that does not allow the motor to start, code says you can use 65% if you want. However, nothing in this question mentioned not allowing the motor to start. So again, we take the FLA that was given to us. Let's change it to red now. The FLA that was given to us, we multiply it by 6 to get our LRC. That gave us 270. We then take 50% of that, which gave us 135. Head on over to table 13, and we go down to 125 amps. And that, my friends, is how you do a cold motor overcurrent question.